Most, if not all, posts on breaches and threat research end with a list of indicators: IPs, hashes, domains, and even URLs. These are usually called indicators of compromise or IOCs, and are useful because they can be used in security products such as SIEMs, EDRs, or even firewalls to block malicious activity. The process of collecting, analyzing, and leveraging these indicators and others, such as threat groups' motivations and targets, is called threat intelligence. Regardless of the cybersecurity field that you choose to pursue, threat intelligence will be present in some shape or form, and your ability to detect and respond to threats will depend heavily on the quality of your indicators. Today I will share with you a simple idea and project that you can leverage to investigate threats or simply practice your skills: a threat intelligence database. Using this database, you can start with a list of indicators that you want to investigate and end with a list of verdicts. The solution will require Python and Postgres running inside a Docker container. And in my case, I am using Docker Desktop for OS X. So let's begin, Spartans. The architecture for today is going to be something like this. Postgres will be run inside the Docker container using Docker Compose. A Python script will pull indicators from multiple feeds, do some processing and aggregation, and store these indicators in Postgres. The reason why I'm running Postgres inside the Docker container rather than installing it locally is because it's much simpler. There is already a Docker container ready to use with a Postgres distribution installed, and that is the one that I'm going to leverage. The Python script will also have a second mode that you can use to query the database based on a list of indicators stored in a text file. The script is going to take that file, query the database for each one of these indicators, and tell you whether the indicators are part of the database and in which feeds they appear. Looking at the screen, you can see that I've already started a base entry point for the script where I list the main function with a proper argument parsing for the command line, and I'm also showing you the list of feeds that I'm going to use. In this case, I have 2 IP feeds and also 2 domain feeds. And as an example, I'm going to share with you a link to a GitHub repository that has several lists of feeds that you can use for your own project. We will work on this project following 3 steps. The first one is going to be bootstrapping Postgres locally using the Docker and Docker Compose. The second part is going to be creating the code that is going to pull the indicators from the multiple feeds, aggregate them, and store them in the database. And finally, we are going to create the code that, based on a file that is passed as an input, queries the database and gives you a verdict. Now, for those who don't know, Docker Compose is a tool and a command that allows you to orchestrate several containers at the same time. This means that you can launch a stack with a database and perhaps a web server to run one or more applications. All you need is a Docker Compose YAML file, which we are going to create next, and Docker Compose takes care of the rest. So let's start by creating a Docker Compose YAML for our Postgres instance. As you can see in this entry point, the script receives 2 arguments. One of them is a -m flag, which is required, and this one allows you to choose which mode the script is going to run in. The first mode is I, which is ingestion, while the second one is S, which means search. The second argument is optional, and you must pass it when we use the search mode. This is the argument that you use to pass the input file containing the domains. In this case, I'm going to use this indicators file. If you watched my previous video on automation, you probably remember some of these domains, but I've added a couple more, and these are present on the feeds that I'm going to use. So as I mentioned, let's begin by creating our Docker Compose file. So first we are going to create a file, Docker Compose, compose.yaml. And in this case, to save some time, I will jump to the final Docker Compose file, and I'm going to explain to you what each section means. If you have seen YAML files before, this is not new to you, but the sections are to an extent self-explanatory. The first one is called image, and this image is used to choose which Docker container image you are going to run. And if you are wondering where is this image, it's stored in the public repository of Docker. If you go to Google and you search for Postgres Docker, you are going to end up in this page. This is the official Docker image for Postgres. And as you can see, this is an example of a Docker Compose file with a Postgres container. And as you can see here, they are putting image Postgres. The latest is just to indicate that I want to get the latest version of this container. It's a tag. Well, let's go back to our Visual Studio Code. Starting from the top, you have the container name. This is going to be used by Docker to give a name to your container locally. You can choose whatever name you want. Then we have the environment section. This section is quite relevant because this is where you are going to pass some parameters to the database. The advantage of using Docker Compose and Docker in general is that you don't really need to configure everything from scratch. And you can pass a lot of configurations using environmental variables or simply files using volumes, which is something that I'm going to talk about next. Starting from the top, we have the Postgres root password. We have the Postgres DB that we want to create, the database name. In this case, I'm calling it cyberspartan_ti_database. Then we have a Postgres user and Postgres password. In this case, I just chose cyberspartan user and cyberspartan password to keep it simple. This is not secret, it's run locally, so there is no real risk of breach. But if you were running this in a cloud or a public server, you should come up with something a bit more clever. Up next, we have the section called ports, and this is where you define the ports that are exposed by Docker. The first port is the port that you expose locally on your local host. When your Python script connects to this port and to local hosts, the traffic is going to be redirected to 5432 inside the container. And this is where the Postgres database is going to be running. This is the default port for Postgres. Finally, we have a section called volumes, and volumes are used to create a mapping between files and directories inside the container and outside of the container. Now, there are multiple reasons why you would use volumes. One of them is to, for instance, pass configuration files to the Docker container and to the application running inside of the container. Another possibility is if you want to save the state or the files that were created inside the container outside of the container, for instance, on a local folder, as I'm doing in this case. The notation to declare volumes can be a bit convoluted, but it's relatively simple. The multiple components are separated by a column, starting with the first component called the source. And the source is the path for the file or the folder locally on your computer, not inside the container. The second component is the destination. To which file or directory is the mapping going to be made? And finally, optionally, as with the first example, you can choose what kind of access will the container have to this volume. In this case, I want the access to be read-only because I don't want the file to be modified. Being more specific and starting from the top, we can see that the first volume is simply a file. I am mounting a file called init.sql, which is relative to the main.py file called mounted docker entry point initdb.d, which is not created yet. And this init.sql is going to be mapped inside the Docker container under root docker entry point initdb.d, init.sql. The second volume that I created is going to be mounted postgres.data and is going to be mapped into var lib postgres SQL data. And this second mapping is used to store and save the state of the database outside of the container. And this is useful because if you delete the container by accident, you can always load and recreate the container later, and the state of the database is going to be kept inside a folder that you control. Now, the first step in our case is creating this local mounted directory that we are going to use. And inside the mounted, we are going to create two folders. Now, we still need the init.sql. The purpose of the init.sql is to bootstrap the database because the database is going to be created using the name that I mentioned before, but you still need to have tables because your indicators are going to be stored on tables. Now, if you are a bit confused about the init.sql that I've just mentioned, you can go to the documentation for Postgres container, and there is a section called initialization scripts where you can find the explanation of this script and this folder. And as you can see here, it says that if you add any file ending with .sql, .sql.gz, or even shell under docker entry point initdb on the root of the container, these scripts are going to be executed to bootstrap the container in the database. we want to create a table for our indicators. And for this table, I'm going to use 4 fields. The first one is going to be the indicator. The second one is going to be the feeds where the indicator appears. The third one is going to be the type of indicator, such as an IP or a domain in this case. And finally, I want to have a timestamp that tells me when was the last time that this indicator was updated or inserted into the database. And we are going to use the indicator itself as the primary key because we don't expect to see this indicator twice on the database. And I've decided once more to skip the formalities, and I added the necessary command, which is an SQL command, to create a table called indicators. Starting from the top, you have an indicator which is type text or string. Feeds is an array of strings because we are going to have multiple feeds for the same indicator sometimes. We are going to have a type, and finally, last updated, which is a timestamp. At this point, we have the Docker Compose YAML, and we have the files ready. But there is something else that you still need to do. For security purposes, you cannot simply pass any path to be mounted as a volume using Docker Desktop. By default, there are several paths that are available, such as /temp. But in my case, because I'm using this specific path inside my project, I need to add it to the paths allowed by Docker Desktop. And you can see in this screenshot how this is done. And we are now in a position to bootstrap our Postgres instance inside Docker with Docker Compose. And it seems that the Postgres instance is now running. What we are going to do now is we are going to connect to the database using a Postgres client that you can download for macOS. There are multiple ways you can install this. You can check online. You can use, for instance, Homebrew. The command is POSQL host port. You are going to pass the database that you want and also the username. And once you click, you are going to be asked for the password. The password is stored here. And you are now connected. Now we can check which tables exist to make sure that our script was executed properly. As we can see, there is a table called indicators, and now let's check the table. And as you can see, the table is empty, but it is created, which is what we wanted. Now it is time to write the Python code to process the feeds and send the indicators to the database. Now it is time for us to write the code to pull down the indicators. We are going to create a folder called utils, and inside this utils folder we are going to create a file called HTTP. This file is going to contain functions, in this case just a function, to perform a GET request and return the response from the server as a string. We start by importing requests, and then we define a function called GET, which receives a URL and the user agent. And the reason why I'm passing the user agent in this case is that some thread feeds actually block your access based on the user agent if they spot that you are using, for instance, Python or any other automated tool. For that reason, we are going to spoof the user agent and use the user agent of a browser. We are going to perform GET requests, but before we need to declare headers. Pass as a first argument URL, and the second one is headers. Then we can return the text or the content returned by the server. Of course, this is not so simple. We need to implement some exception management, and also we need to check what is the code returned by the server, because what we want is a code 200. If there is something different from that, then we need to print the error and return something that indicates that the request failed. So we create a try except block as before. And in this case, if there is an exception, we are going to return none rather than a string, meaning null. I'm going to print an error in a fairly standard way. As you can see, in this case, there is an exception. I'm going to say request.get returned error E, and finally returns a none. But also we need to check what is the code returned by the server. If the status code is 200, then we return the response. Otherwise, we are going to do a print of the status code and return none or null. Now that we have our HTTP module, it's time for us to leverage it to download the indicators. Now we are going to create a folder called Intel, where we are going to store our codes responsible for querying the feeds and aggregating the data. Inside this folder, we are going to create a file called feeds. And this is probably the biggest file of the entire project. We start by importing the HTTP model that we just created. Then we are going to declare our function, and we are going to start by declaring three things. The first one is the user agent that we are going to use, which is the spoofed user agent. And then we are going to declare two lists, and these lists are going to contain the URLs for the feeds. Now let's go back to the original objective. We want to store in the database a list of indicators, their type, a timestamp, but also the feeds where they are. And for that reason, we are going to return from this function a map, and the map is going to contain as two main keys, IPs and domains, because we are just working with these two for now. Now, as you can see, I'm creating a map, and inside the map there are two submaps. And these maps are going to contain a mapping between the domain and the lists of feeds where this domain appears. Because we have two lists of feeds, we are going to create two for loops. First, we are going to download the feeds using our HTTP module. As the first argument, we are going to pass the URL, because IP's feed is a URL for the feed. And as a second argument, we are going to pass the spoofed user agent. Now, this is going to return a string, which is basically the content of the feed. Now, we can take as an example one of the feeds, and we are going to look at the structure of the feed. As you can see, there is a list of IPs here, but there is also a banner on top, which starts with a bunch of hashtags. There are multiple ways for you to extract these indicators. Probably the most scalable way is for you to use a regex that matches on IP patterns. But in this case, for simplicity purposes, what I'm going to do is I'm going to simply split the entire string based on new lines. And then I will check for each if the list starts with hashtag. If the list starts with an hashtag or with an empty character, as you can see here, I'm just going to skip. And this is how I'm going to remove the banner. So first we need to make sure that something returned from this function. We have to do if IP's feed data is none. We are going to do a print and continue because we don't want to keep processing. Otherwise, we are going to process the content returned by the server. I'm going to now check if the line starts with hashtag or empty character. And if it does, I'm going to simply continue this loop. And remember, this is a nested loop. The top loop is going to loop through all of the threat feeds, while the second nested loop is going to loop through all of the indicators returned by one of the feeds. Now, what I need to check next is if this indicator is part of the map that I've declared above already. Now, because this is a loop and the map on top is going to be modified, for every iteration I need to do some checks. Now I'm going to check if this indicator is already present on the map. If it's not present, I'm going to add it, and I'm going to also add a set associated with this indicator. Now, as you can see here, I'm adding the indicator to the IPs map, and I'm also mapping a set to this indicator. This set is going to be used to store the lists of all feeds where this indicator appears. I'm simply using a set to avoid duplication of feeds for the same indicator. Now, this is the case where the domain doesn't exist yet. If it exists already, I'm going to simply add the feed to the existing set. And this is all we need to do to process the IPs. Now we can process the domains in exactly the same way. And for that reason, I'm simply going to skip ahead and show you the result. And this is the loop that is going to process the domains feed. As you can see, it's exactly the same thing. The only thing that changes is the name of the variables and even the prints. Once you reach this point, the map is already created and it is time to return it. Now we want to test if this function worked or not. So we are going to call it from main. And because we need to pass some command line arguments, I'm going to prepare the ifs and the else that are going to deal with that. So these are the two possible switches that you can use for the mode. In this case, we are going to test the first one. We are going to import feeds. And now we are going to pull down the indicators from the feeds. And now we are going to simply run this. And as you can see, it seems to be working. Now it is time to create the code to store these indicators in Postgres. We are now going to create a folder called db. And inside of this folder, we are going to create a file called Postgres. Now, in order to interact with Postgres, we are going to use a Python module called psycopg. which sounds a lot like a wrapper, but it's completely different. And if you want to install it, you can simply run pip install psycopg. And for this tutorial, I assume that you already have pip installed on your device. Now we are going to import a sub module called SQL. Now we need to declare a global variable called db parameters, which is going to be used by all functions that interact with Postgres. And this structure is a map. And as you can see, it contains the host, the port, the database, the user, and the password. And some of you are probably shaking your heads in disbelief because I have a password hard-coded on the code. But as I mentioned at the beginning, this is simply an example. It's running locally, so it doesn't really make a difference. There is no critical API key or password that can be exposed. But if you are paranoid enough, you can use environment variables, as I have explained on my previous tutorial. We are going to create a function called insert indicators, which is going to receive a list of records. Now we are going to declare a template of the SQL query that is going to be run against Postgres to insert our indicators. In order for us to insert the data into the database, we are going to use an insert directive. And because this is a database with indicators, it's quite likely that if you run the same script twice, you are going to insert the same indicator twice. But because the indicator is actually a primary key, you cannot insert it twice because it already exists. And for that reason, I'm using another directive which is called onConflict. And what's going to happen is that if there is a conflict with indicator and if the indicator is already there, the entire record is going to be overwritten with a new value. So that means that every time you run your scripts, the database is going to be updated with the latest indicator, feeds, and also the timestamp. As you can see, there are curly braces here that are empty, and there are also several placeholders for strings. This is going to become clear as I write the rest of the code. Now we know that the table name is indicators, and as you can expect, there is the possibility that Postgres client is going to throw exception, so we need to try except. Now first of all, we need to connect to the database, and for that we are going to create a connection. Now, as you can see, the connect function receives multiple parameters, but all the parameters are saved in a dictionary. The way for us to assign each one of these values to the right parameter on connect is to use the unpacking notation that Python has. In this case, it is the double asterisk, which is used specifically for dictionaries. Now that we have a connection, it is time for us to create a cursor. And the cursor is actually going to be the object that we are going to interact with to execute queries. Now this function is expected to receive a list of records, which can mean thousands of records. What we are going to do in this case is we are going to leverage a capability of most databases called a transaction. And a transaction is basically a large set of queries that you run in batch, and if one of these queries fails by any reason, the entire transaction is cancelled and rolled back. The reason why we do this is because we don't want to insert just a few records and miss the others. We want to insert everything or nothing. In order to create a transaction, you need to start with a command called begin. And remember that when you run a cursor execute, you are actually running a SQL query. And if you have a begin, you also need a commit. And because I like prints, if we actually reach this commit, it means that the transaction was executed successfully. Now, between the begin and the commit is where the fun happens. First of all, we are going to create what is called a parameterized query. And the reason why we create a parameterized query using this construction that I'm about to show you is to avoid SQL injection. In this case, it's not really a risk, but this type of query is a standard and it's the proper way to create queries with parameters that are passed to functions. So we declare an insert query, and we are going to pass as the argument the insertion query that appears at the top. This is similar to a format string where you start with a string that needs to be parameterized, and then you pass the arguments that are going to be replaced on that string. And in this case, we are going to pass the table name, and we are going to replace this so that the query looks like insert into indicators. So we declare identifier. Now the query is parameterized, but there are still arguments that need to be passed. And this is where the next loop comes in. We are going to iterate through each element of the initial list, and we are going to execute a command. This is the query, and this is the record. And this notation may be a bit confusing, but what is happening here is basically this record is a tuple, and the tuple contains several fields. And when you run this cursor execute, each one of the fields is going to be mapped specifically to each one of these string placeholders in order. This is all the code that we need to insert data into the database. But something that we want to do before leaving this segment is creating a finally block. And the finally block is going to execute commands before it leaves the function, regardless of whether the leave was caused by an exception or simply by a return. And in this finally block, you want to close resources associated with the database. We declare a finally block, and here we do cursor, close, and con. We close the cursor and we close the connection. And at this point it's ready. So we are going to test it now. We are going to once more bootstrap our database. And what we are going to do now is the code responsible for calling the insertion function. First of all, we need a timestamp, and we can get this using the date time, which basically gives us a time for now, a timestamp for the exact moment when this command is executed. And we need to import date time. We start with the insertion of IPs. Now remember that we need to generate a list of records, and the record is a tuple, and the tuple must obey the same order of insertion into the database as the original query. So looking back here, it means that this first argument must be an indicator, the second should be the feeds list, the third should be the type, and the fourth should be last updated. This is what we are going to do now. We start by creating a list. Now remember that the map that we return from the function pull malicious indicators contains two submaps. The first one is IPs, the second is domains. And these IPs and domain submaps inside of the main map contain a mapping between a domain and a set of threat feeds. So we need to create a record now. We declare a record like so, and remember that this record is a tuple. We declare a tuple. The first element is going to be the malicious IP. The second one is going to be the list of feeds, and in this case it needs to be a list, not a set. The third element of the tuple is going to be the type of indicator, which in this case is an IP. And the final is the timestamp. And now we are going to add this tuple to our list. Now that we created our list of tuples, it is time to call our function to insert them into the database. And we need to import our Postgres module. Now, this is what you do to process and insert the IPs, but we need to do the same for domains. And because the loop is the same with the small differences on variables, I'm going to simply skip and show you the final result. And this is the final result. Now, our database is running, so we are going to run our script, which is going to insert all the indicators, both IPs and domains, into Postgres. And I've realized that as I was running this code that I had the wrong name for the function. The function should be insert indicators rather than the other one. As you can see, there are some logs on the right side saying that there is a transaction in progress. And now the second one is the domains transaction, which is slower because there are way more domains. And don't forget to stay hydrated. And as I was running the script to test, I realized that I made a mistake. Looking back at the feeds.py, I realized that the second loop was actually nested inside the first loop, the top one, which is incorrect. They should be two different loops. One is iterating on IP's feed, the second on domains feed. And I also noticed that there were some remnants of a copy-paste that went wrong, where I was basically referencing the IP's map inside the domains map. So this is the final code and this one is correct. So now we run again the feed, and as you can see, both transactions were executed. Now let's connect to the database. Now we are going to run this command, and we have all the indicators. Now I want to find out which indicators actually appear on multiple feeds, and there is a query for that. And this is the query. Select asterisk from indicators where array length fits. In this case, array fits is bigger than 1. And as you can see, there are a couple of them. For instance, the indicator 1.25.253.202 appears on scene score and also on binary defense. And we now have our feeds ingested into the database. It is now time to create the code that is going to query the database based on a list of indicators passed on a file. For this last part of the video, we need two things. The first one is a function that is going to read a file and return a list of strings. This one is pretty easy. And the second one is going to be an extension to our existing Postgres module to search the database. We are going to start with the hardest. So now we are going to create a function that is going to query the database using select. And in this case, we are going to receive one indicator rather than a list. The query is going to be different from the other one. Once more, we are going to have a try except block and also a finally block. We are going to do the same, create a connection, create a cursor, and we are also going to parameterize the query as we've done before to avoid SQL injection, like so. In this case, there are two variables that we need to declare. One of them is table name, and the table is called indicators. And the second one is primary key, because we are going to do a where, a match on the primary key. And the primary key is indicator. In this case, we need a selection query. Now we are going to execute the statement. And just to remind you, this parameterization is going to basically match table name and primary key to these two empty curly braces. Now we are going to run an execute, and the execute is going to receive a select query and the indicator. But the indicator must be passed as a tuple. It cannot be a single value, because remember, the execute is going to take a tuple and is going to match it to the existing parameters. In this case, there is just one, so we are going to create a tuple with one value only. And because Python is kind of dodgy, you need to add this semicolon after indicator to indicate that it is actually a tuple. Otherwise, Python is going to think that it's simply a single value. Now, what we want to return from this function is a list of records. We want to return all the records because they are going to be used later. And for that reason, we need to iterate and fetch all the records from this cursor. The way we do this is we call cursor fetch one. But of course, we need to fetch all of them. For that reason, we need a while true. And now what we are going to do is we are going to check if result is none, if it returns null, then we break the loop. Otherwise, we add it to our list of records. And now we need to declare this list of records on top. As usual, if there is an exception, we do a print and we return the empty list. And finally, we have to release resources. And we do this inside the finally block. Finally, we return the list. This one was a biggie. The next one is going to be a module that we are going to use to read the input file and return a list of strings. And this one is going to be pretty easy. Under utils, we are going to create a file called file. And this file is going to do something really simple. We are going to call it read file lines. And we are going to receive a file path. And you are not familiar with this, so I'm just going to skip ahead. There is nothing new here. What we are doing here is basically opening a file in read mode. And then we are reading the entire file, splitting it by new lines. And then we are going to return a list of lines, which in this case is going to be a list of indicators. We go back to our main function. And in this case, we are going to simply call, we start with indicators list. We need to import file. And we are going to pass as an input the input file. Now that we have the lines, we are going to iterate each one of them, which is actually an indicator, and we are going to search the database. So for each indicator in indicators list, we are going to pull all the records that match this indicator. And now we are going to simply check if the length of this list of records is bigger than 0. That means that there is a match, and we are going to do a print. Now, this indexing may be a bit confusing, but what I'm doing here is getting the first record out of the list of records, and then I'm indexing the second element of the tuple, which happens to be the list of feeds where this indicator is. In this case, this first 0 is kind of irrelevant because there is only going to be one record that matches the indicator that I'm searching for, or 0. But because we are returning a list, I must index it like so. Even if it's just one element, I'm going to index the first and the only element, and then inside that element, which has tuple, I'm going to index the second element, which happens to be the list of feeds. Now we are going to bootstrap our database again, and now we are going to run our search. Now we run the script, and remember that the mode is now S, which means search, and we are going to pass as a second argument the file, which is going to be the input file containing the indicators. We run, and we can see that the script says searching DB based on file inputs indicators, indicator Lucifer web host app found on database, and these are the feeds. And the second one is the IP found on the database and feeds binary defense. And these were the only indicators that were part of the feeds that I was ingesting. The rest were not, and for that reason they were not found there. Now be honest with me, this is pretty awesome, right? And that is it. And that's it for today, Spartans. You are now able to put together a simple database with indicators from multiple open feeds. You can use this database and this script to assist you with your investigations. This is a quick and dirty approach, and it is far from perfect. Choosing indicators and maintaining them is an art and a science, which is out of scope for this video. And if you are wondering what I mean, just ask yourself these questions. What happens if the indicator is not malicious, and the person or team putting together the feed is wrong? Why is this indicator in this feed? What's the context? And finally, and probably the most important, how will you know when that indicator is no longer malicious? As an example, assume that the website was compromised and was hosting a phishing page for several months. When are you going to be notified about the cleanup and the fact that the website is now legitimate? These are all legitimate questions. And this is also why there are entire teams and even companies dedicated to threat intelligence. Until next time, stay safe, stay paranoid.